Assalamu alaikum, good afternoon everybody. Welcome to the session number 8 of the second International Conference on Molecular Modeling and Spectroscopy. It gives me great pleasure to introduce this session that deals with laser and its application in spectroscopy. I am Rania Badri. I will introduce the session number 8. The session consists of 10 orals. Session 8, oral session 3. The oral session starts from oral number 23, Untitled Treatment of Breast Cancer Using Photothermal Therapy Induced by Laser Activated Gold Nanoparticles by Dr. Hind Jamal. Oral number 24, Assessment of Heavy Metals Content in the Agricultural Soils of Kafr Zayat City using laser ablation inductively coupled plasma mass spectroscopy and inductively coupled plasma optical emission spectroscopy by Dr. Asma. Oral number 25, Determination of Electron Temperature of copper iodide lines at 515, 521 and 522 nanometer using ultrafast LIBS by Dr. Walid Tawfiq. Oral number 26, under title Physical and Electrical Characterization of BVB, BVA matrix doped by gold nanoparticles prepared by laser ablation by Dr. Abdurrahman. Oral number 27, under title Aluminum Surface Modified with Hydroxyapatite Sputtered via Pulsed Laser Deposition Technique for Biomedical Applications by Dr. Muhammad Afif. Oral number 28, Coarse Shell of AU and SE nanoparticles incorporated via laser ablation technique into the polymeric nanofibers scaffolds of cellulose acetate and BVDF for wound healing applications by Dr. Muhammad Ahmad. Oral 30, under title Synthesis of Nanocomposite Materials via Pulsed Laser Ablation Technique by Dr. Ayman. Oral 31, under title Facile Laser Assisted Fabrication of Carbon Nanostructure Decorated Membrane for Water Treatment by Dr. Iman. Oral number 32, under title Optical Emission Spectroscopy for Concrete Strength Evaluation Utilizing Calcium Lines by Dr. Muhammad. Oral number 33, under title Synthesis and Antibacterial Activity of Ketosane inlaid by various ratios of bimetallic gold silver nanoparticles via laser ablation by Dr. Asma Ismail. Let's start with the first oral in this session with the oral number 23.
Treatment of breast cancer using photothermal therapy induced by laser activated gold nanoparticles. Researcher name Hind Jamal. Supervisors Dr. Walid Tawfiq, Dr. Hiba Muhammad Fahmi, Dr. Hassan Ibrahim Hassan Sayad. Department of Zoology, Faculty of Science, Mansoura University. National Institute of Laser Enhanced Sciences, Cairo University. Department of Biophysics, Faculty of Science, Cairo University. What is a tumor? A tumor is a mass of tissue that formed by an accumulation of abnormal cells. Normally, the cells in your body age, die and are replaced by new cells. With cancer and other tumors, something disrupts this cycle. Tumor cells grow even though the body doesn't need them, and unlike normal old cells, they don't die. As this process goes on, the tumor continues to grow and more cells are added to the mass. What are the two types of tumors? Benign, non-cancerous tumors, malignant, cancerous tumors. Cancer is a disease state caused by abnormal cell growth and is the third leading cause of mortality worldwide. According to the World Wide Organization, cancer caused 88 million deaths in 2015. Current cancer treatment is based on chemotherapeutic drugs, usually involving chemo or radiation therapy, with the aim to kill the cancer cells. However, these treatments often result in several side effects due to the damage caused to the surrounding healthy tissues. Breast cancer. Breast cancer is cancer that forms in the cells of the breasts. After skin cancer, breast cancer is the most common cancer diagnosed in women in the United States. Breast cancer can occur in both men and women, but it's far more common in women. The type of breast cancer is determined by the specific cells in the breasts that are affected. Two types: ductal carcinoma in situ, invasive breast cancer. According to the Jefferson Health Breast Cancer Awareness, about 1 in 8 U.S. women will develop invasive breast cancer over the course of her lifetime. More than 3.3 million breast cancer survivors are alive in the U.S. today. A man's lifetime risk of breast cancer is about 1 in 1,000. In 2017, new cases of invasive breast cancer will be diagnosed in men. About 5% to 10% of breast cancers can be linked to inherited gene mutations. About 85% of breast cancers occurs in women who have no family history of the breast cancer. Entrance to nanotechnology. Nanotechnology refers to the branch of science and engineering devoted to designing, producing, and using structures, devices, and systems by manipulating atoms and molecules at nanoscale, having one or more dimensions of the order of 100 nanometers, 100 million of a millimeter, or less. Comparison between the nanomaterials and bulk materials. Definitions. Nanomaterials are particles that have their size in 1 to 100 nanometer range, at least in one dimension. Bulk materials are particles that have their size above 100 nanometer in all dimensions. Sized nanomaterials essentially have their dimensions in between 1 to 100 nanometer. Bulk materials essentially have all their dimensions about 100 nanometer. Visualizations. We can't see particles of nanomaterials from the naked eye. We can see particles of most of the bulk materials from the naked eye. Examples. The examples of nanomaterials include nanozymes, titanium dioxide nanoparticles, graphene. The examples of bulk materials include plaster sand, gravel, cement, slag, salts. Why nanoparticles? Their dimension of less than 100 nanometer exploit the increased vasculature permeability and decreased lymphatic function of tumors. Also, nanoparticles can be attached to specific cancer cell targets with non-invasive implementation, increasing the cellular uptake efficiency, selectivity, and the localization in tumor cells and tissues. Characteristics of the ideal photosensitizer: minimal photosensitivity, resistance to photobleaching, optimal treatment regimes, ideal photophysical properties, high single oxygen quantum yield, maximum light toxicity. As we see, cancer tissue with photosensitizer loaded on it. Gold nanoparticles. Gold nanoparticles possesses unique optical and surface plasmon resonance properties due to which it has become the first choice for researchers, particularly in the biological field. Due to the optical properties of gold nanoparticles, they are especially utilized in ultra-sensitive detection and imaging-based therapeutic techniques required for the treatment of lethal diseases such as cancer. Important properties of gold nanoparticles: it has surface functionalization, so we can load drug or gene or protein on it. It has fluorescence properties that enable us to make imaging. It has tunable size and shape morphology that enable us to use. It has biocompatibility properties that can we use in animals uh, cell cell lines. An example of drug delivery using gold nanoparticles. This is the way of how they load drug on gold nanoparticles. At the end, as we see, docs loaded fucodine capped gold nanoparticles, and in the end, the cells with dead cell or apoptosis due to the drug that loaded on gold nanoparticles. Photodynamic therapy, as we see, light with photosensitizer has two papers, photochemistry papers that lead to tissue death, and fluorescence papers that enable us to image. B. The sequence we use: first administration, then accumulation and light delivery via fiber optics, and at the end assessment. A photosensitizer is a photoactivable multifunctional agent which, upon light activation, can serve as both an imaging agent and an therapeutic agent. B. Sequence of administration, localization, and light activation of the photosensitizer for photodynamic or fluorescence imaging. Mechanism of photodynamic therapy: light with photoactive drug lead to the normal oxygen to be free radicals or reactive oxygen species. Photodynamic therapy initiates cellular apoptosis. Prospective study: we will choose one suitable type of mammals, rabbits or rats or cats. Cancer may be natural or implemented according to what the animal we will choose and what savors the study. Groups will be categorized into diagnostic group, treatment, that divided into normal without nanoparticles, with nanoparticles, with laser, without laser. Comparative studies will be done for all groups. Side effects still include: first, clinically decreased tumor selectivity, leading to skin photosensitivity and harm to normal healthy cells. 2. Limited solubility. Most first and second generation of photosensitizers are hydrophobic. Conclusion: advanced non-invasive method for breast cancer treatment is presented using nanotechnology and low-power infrared laser beam in photodynamic therapy. The interaction dynamic of the nanogold particles with the tumor cells is studied. An example of drug delivery using gold nanoparticles is given. The mechanism of photodynamic therapy and the generation of reactive oxygen is demonstrated. Thank you.
Bismillahirrahmanirrahim. My name is Asma Fakima Noula, supervisors Prof. Walid Tawfi, Prof. Faroul Mekkawi, Prof. Muhammad Shaheen, and two assistant Fryer and Gagnon. By title Analysis of Agriculture Soils of Kafr Zayed City using laser ablation, inductively coupled plasma mass spectrometry, and inductively coupled plasma optical emission spectroscopy. Outline: aim of this work: introductions to heavy metals, material and method, result and discussion, conclusion. Aim of this work: determination of heavy metal content in soils around Kafr Zayed City using laser ablation, inductively coupled plasma mass spectrometry, and inductively coupled plasma optical emission spectroscopy. Evaluation of the analytical performance in terms of accuracy and precision of the laser ablation ICP-MS and ICP-OES. Introductions to heavy metals. Heavy metals naturally originate in the Earth's crust and are introduced to the environment through various anthropogenic sources or activities such as mining, traffic, agriculture, and industrial activities. Heavy metals is a term that is generally used to refer to a group of metals and semi-metals metalloids that have densities greater than or equal to 3 grams per centimeter square and can cause harmful biological effects and ecological problems when present in sufficient concentrations. Determination of heavy metals in agricultural soils is of great importance due to their adverse effects on plants, animals, and humans. Heavy metals can accumulate in the environment and can reach humans through food chain. The evaluations of heavy metals in soils is essential to assess the danger to food chain and to evaluate their environmental impact. Study area. Soil sample were collected in Kafr Zayat city. Kafr Zayat belongs to El Gharbia Governorate and is one of the most important agricultural and industrial cities in Egypt. Kafr Zayat is the home of many industrial facilities such as oil, paper, pesticides and chemical factories, which are the source of heavy metals contamination in the area. Study area in Kafr Zayat is shown in this map. Sample collection and sample preparations. 5 samples were collected in Kafr Zayat city at a depth of about 25 centimeters. The sample were mixing and placed in clean plastic bags. The sample were left to dry under sun for about 3 days and then cleaned manually. Sample were manually ground using mortar and pestle and then sieved using meshes of different size to obtain small particles. After drying process, sample ground using mortar and pestle is shown in this figure. This powder then sieved using meshes of different size and pressed into pellets of 1 cm diameter and 0.3 cm thickness for analysis by laser ablation ICP-MS. Sample preparation for ICP-OES. In ICP-OES, 1 gram of each soil sample was digested using a mixture of concentrated nitric and hydrochloric acid as a ratio of 1:3 and heating on a hot plate at a temperature of 120 degrees Celsius for a few hours. After digestion, the sample were filtered and placed in clean bottles for analysis by ICP-OES. As this figure shows sample preparations for ICP-OES. Analytical Techniques. The sample were analyzed at the Great Lakes Institute for Environmental Research, University of Windsor, Canada, using laser ablation ICP-MS and ICP-OES. Laser ablation, inductively coupled plasma mass spectrometry. We use excimer laser, wavelengths 193 nanometer, pulse width 4 nanosecond, energy 2.9 millijoule, spot size 25 micrometer, scan speed 5 micrometer per second, repetition rate 20 Hz. ICP-OES, the shapes of inductively coupled plasma optical emission spectroscopy technique. Result is ICP-OES. Sample preparation wasn't efficient in extracting the total metal content in the soils, and the result had to be corrected for using standard reference material. I used marine sediment reference material, MIS3. This figure shows the accuracy and precision by using ICP-OES for marine sediment reference material. Result is laser ablation ICP-MS. This figure shows the relation between signal intensity of cobalt, nickel, and copper, and the time second in standard reference material by using laser ablation ICP-MS. This figure shows the signal intensity of cobalt greater than the signal intensity of copper, greater than the signal intensity of nickel. Analysis of standard reference material by laser ablation ICP-MS marine sediment reference material. Laser ablation ICP-MS gives accurate measurements with minimal sample preparations. As shown in these figures, accuracy and precision by using laser ablation ICP-MS. Analysis of agricultural soils laser ablation ICP-MS versus the ICP-OES. This figure shows the concentrations, the heavy metals, the parts per million by using laser ablation ICP-MS and the ICP-OES and the precisions the two techniques. This table shows the concentrations part per million of heavy metals in soil sample by using laser ablation ICP-MS and the standard deviations with ICP-OES with standard deviation and compare with Canadian soil quality guidelines. This figure shows the concentration sample part per million of heavy metals in soil samples by using two techniques, laser ablation ICP-MS and ICP-OES, and conversions to Canadian soil quality guidelines. This figure shows the concentrations of LV, chrome and nickel exceeds the concentration levels of the Canadian soil quality guidelines. Conclusions: the method of sample preparations by ICP-OES wasn't efficient in extracting the total metals content in the soils, and the result had to be corrected for using reference materials. Accurate analysis of soils using ICP-OES requires time-consuming sample preparation steps and the use of aggressive acid such as HF for the total element extractions. ICP-OES was less accurate than laser ablation ICP-MS due to the inappropriate digestion method applied during the sample preparations of the agricultural soils for analysis by ICP-OES. The precision of the most element was better in ICP-OES than in laser ablation ICP-MS. This can be attributed to sample homogeneity issue. The concentrations of LV, chromium, and nickel exceeds the concentrations levels of the Canadian soil quality guidelines. This indicates high contaminations of these elements.
Thank you to give me a chance to present our recent paper about determination of electron temperature of copper for three characteristic lines, 515, 521, and 522 using ultrafast LIBS. LIBS is acronym for laser-induced breakdown spectroscopy. This work has been done in Cairo University, Department of Physics, as will be shown in details. Ultrafast laser-induced breakdown spectroscopy is a combination of using ultrafast pulses and laser-induced breakdown spectroscopy. Outlines of our paper contains ultrafast lasers and LIBS. LIBS as elemental analytical technique, LIBS spectrum of copper, plasma electron temperature and electron density, then conclusion. In Cairo University, the construction of Cairo University is well known since 1908, and the College of Science since 1925, and the foundation of the National Institute of Laser since 1994. Why you have to go for ultra fast pulses? This is because we found one round trip of electron around the atom takes around 152 attoseconds. In addition, some molecular vibrations takes some kind of ultra-fast intervals from picosecond to almost femtosecond. The absorption itself takes something like 1 femtosecond, so that we have to use ultra-fast pulses to follow all these kind of dynamics and interactions. New ultra-fast laser spectroscopy group in collaboration with Professor Magdi Omar and Dr. Muhammad Fikri. In this laboratory we have ultra-fast laser pulse with a pulse duration of 170 picoseconds. This laser can generate the 4 harmonics starting from infrared around 1064 nanometer to green 532 and UV around 355 and ultraviolet deep ultraviolet 266 nanometer, and pulse energy around from 25 to 500 millijoule. And this laser picosecond laser depend on well-known technique of sharp pulse amplification, at which we start with expanding the pulse duration, then after amplification we compress the pulse duration again to get a very high intense pulse of picosecond laser. This is a setup used for the generating plasma of the sample, and the emission of this plasma give us a spectrum of the used sample using kind of a suitable spectrometer and CCD camera. The interaction of ultra-fast LIBS with the sample can be demonstrated as shown after the emission of plasma plume. The emission of this plasma plume can give us a detailed emission lines of the and the characteristic lines of the copper in this case. This is characteristics lines of the copper, and now for determination of electron temperature and the effect of the wavelengths of the ultra-fast laser on the generated plasma, we have generated different plasmas using different wavelengths and the same laser energy of 60 millijoule. And we have characterized each spectra for each wavelength, and we analyze all the observed results. For full characterization of the observed spectra, we have to consider the transition spectroscopic parameters, including the transition from the upper to the lower levels for the 515, 521, and 522 characteristic lines, and the transition probability and the energies for these transitions, and the statistical weight for the transition probabilities of the observed lines. Of course, we have different types of plasma and different types of conditions which can be applied to generate such plasma. One of the most important conditions is a local thermodynamic equilibrium, at which we consider that the observed plasma is optical thin plasma, at which electron density is almost equal to plasma density, and density of ions almost is equal to density of electrons. and the plasma is almost homogeneous in the very tiny area at which the plasma is generated. Now for determination of electron temperature, we have used Boltzmann method, at which this method we can consider the emission intensity and the electron temperature, which related to excitation energy of each level. This is the used parameters in this relationship, which we have considered in our calculations. Using the Boltzmann method, we got the Boltzmann plots for the three characteristics lines using the different laser wavelengths and same laser energy. From these Boltzmann plots, we can previous figures of Boltzmann plots, we got the plasma electron temperature for each laser wavelength, and we found that the electron temperature increased with the laser used laser wavelength, and we consider how much the temperature changed from around 13,000 Kelvin to 20,000 Kelvin. Now we will try to understand the explanation why the temperature is increased with the used laser wavelengths. In the beginning of the generated plasma, a part of this plasma can absorb the laser beam by electron ion inverse Strauling and photoionization. The probability of electron ion interaction is much common than that by the electron neutral, except at the very early stage of the laser evaporation process, and according to that, electron neutral is generally considered negligible during laser induced plasma processes, while the inverse from Strauling absorption and the photoionization coefficient alpha IB and alpha BI can be given as the following. From these relations, we have found that inverse from Strauling is most probable for near infrared, while photoionization is most probable for the UV, and from this we can conclude that spectroscopic studies is found from using ultrafast neodymium laser at 4 wavelengths to generate copper plasma, and the temperature is determined for 3 different wavelengths, 515, 521, and 522 nanometer, and the results show that the electron temperature of the plasma increases with the increase of the laser wavelength. Thanks.
Today my lecture with high-del physical and electrical characterization of BVB, BVE matrix, doped by gold nanoparticle prepared by laser ablation. My name is Abdurrahman A. Menazi, Laser Technology Unit, Physics Division, National Research Center and Spectroscopy Department, Physics Division, National Research Center. In our lecture outline, we'll talk about abstract introduction and the material and the method, then results and discussion, conclusion. In abstract, the recent work, I prepared gold nanoparticle by laser ablation technique and doped it in matrix between BVB and BVA. The prepared nanocomposite have been obtained by casting technique. The prepared sample have been characterized to study the physical and electrical conductivity of the prepared sample to enhancement its electrical conductivity. Introduction, we will talk about pulsed laser ablation of solid and liquid and polymer blending. Then we'll talk about composite of polymer metal nanoparticle. Pulsed laser ablation of solid and liquid PLAL considered an easy and modern method of manufacture nanoparticle of high quality that have different advantage over other methods. Laser ablation is a wonderful novel method as having a simple experiment setup for the processing of strong quality nanoparticle of shape and scale and chemical composition. Several researchers have been evaluated the production of gold nanoparticle by laser ablation process and found the high quality of the prepared gold nanoparticle in comparing by that prepared by chemical method. Polymer blending considered one of the best methods to creating polymeric material and produce product with a various characterization. Composite of polymer with metal nanoparticle is currently considering the desire for producing new theories to develop a new product with characteristics that show advantage in terms of electrical, mechanical, and microstructure application. Now results and discussion. We will talk about the figure A and B that can obtain the X-ray diffraction XRD pattern of pure BVB and pure BVA, and the figure B, BVB, BVA blend doped by different concentration of gold nanoparticle. XRD scan data obtain pattern of pure BVB BVA. We will heart to BVA. BVA, the pattern of pure BVA at 2 theta 16 and 0.5 and 40.5 and show shoulder at 22.7. That can be attributed to the blends of 110 and 200 and 220. Then in pure BVB, the figure obtained two high peaks at about 11.83 and 20.87 that approve the semi-crystalline nature of BVB BVA. In the second figure, we can show the effect of gold nanoparticle by increasing the concentration of gold nanoparticle from S1 to S4. We can find that the ratio of gold nanoparticle can increase, and this big attributed to the presence of gold nanoparticle that can the intensity of this peak decreasing by increasing the concentration of gold nanoparticle. Also, we found that this two peak can decrease by increasing the concentration of gold nanoparticle. The gradual vanishing of the characteristic peak by enhancing the amount of gold nanoparticle. This decreasing indicating the rearrangement of gold nanoparticle within BVB-BVE matrix, indicating the decreasing of crystallinity, which may confirm the interaction between gold nanoparticle and BVA-BVB. According to this peak, we can calculate the crystallite size of the prepared gold nanoparticle by the Pi-Scherrer equation, and found to be 19.43 and 32 to 32.76. The optical properties: A represent UV visible absorption spectra, B loss of absorption coefficient alpha versus H nu of PVB BVA blend doped by different concentration of gold nanoparticle prepared by laser ablation. The spectrum of PVB BVA obtains the presence of a peak at 220, related to the transition between N state to the pi star state, electronic transition. The spectra of BVB BVA gold nanoparticle film at various concentration of gold nanoparticle obtain shift of peak at by increasing. We found shift in the peak of this peak. Also, the BVA gold nanoparticle represent significant absorption peak of 536 nanometers that approved the embedding of gold nanoparticle in BVB matrix. The intensity of this peak increased by increasing the concentration of gold nanoparticle, as obtained in more resolution in this figure. When the concentration of gold nanoparticle embedded in BVA matrix, the optical alpha is increased by increasing H nu. The absorption energy of BVA blend is equal to 5.03 electron volt. This value decreased dramatically as the concentration of gold nanoparticle increased. Till get the value 4.88 electron volt for the sample of high concentration of gold nanoparticle that doped in BVA. In the another slide, A represent loss of alpha H nu square. The direct and the indirect band gap. The direct and indirect energy band gap of the prepared sample nanocomposite could be calculated by two correlation. It was 5.07 electron volt, and by increasing the doping of gold nanoparticle, it decreased to 4.93. And in this case, for the direct energy band gap, it decreased from 5.16 electron volt to reach at the high concentration of gold nanoparticle reach 5.14. The scanning electron microscope field emission scanning electron microscope in the pure blend, the surface morphology of the prepared sample has been discussed. Figure 4A obtains the field emission scanning electron microscope that display a clear homogeneous of the prepared sample and demonstrates the compatibility between two BVB and BVA. In figure B, limited bright gold nanoparticle by fine homogeneous distribution. This gold nanoparticle can increase by increasing the concentration in the sample, and in the last sample we found aggregates in the surface with high percentage. After that we can talk about the electrical conductivity, AC electrical conductivity. The electrical conductivity of the prepared sample at various concentration of gold nanoparticle have been evaluated at room temperature as a function of log F. the dielectric analysis, the plots of both real epsilon dash and imaginary part epsilon double dash of dielectric of the prepared sample. The real and imaginary parts of dielectric have a high value in low frequency that have been decreased by increasing the frequency. He'll get low constant value in the high frequency, and this behavior could be attributed to the charge accumulation within the composite at low frequency by increasing the doped gold nanoparticle within BVB matrix. The value of real and imaginary part of the dielectric have been increased, and this value decreasing obtained totally get the constant value at higher frequency. Conductivity analysis. This two figure obtained the real part and the imaginary part of sigma. AC conductivity of the prepared film. The value of real part of AC conductivity show a constant value at lower frequency, and this value have been increased dramatically by increasing the doped gold nanoparticle within BVB matrix. It was obtained in this figure that the imaginary part of AC conductivity had a small constant value at low frequency that decreased by increasing the frequency. All the value of sigma at the high frequency have been increased as the doping of gold nanoparticle increased. Conclusion. In our study, BVE matrix have been embedded with gold nanoparticle to obtain the enhanced electrical conductivity of the blend. Gold nanoparticle were prepared by laser ablation. The structural characterization shows significant sharp diffraction peak at 2 theta 38 degree, attributing to the plane 111 related to the doping of gold nanoparticle. According to our result, it will show a presence of the characteristic peak of gold nanoparticle in UV absorption spectra at 536 nanometer. The electrical conductivity data approved enhancement of the performance of the pure blend BVA after embedded with gold nanoparticle prepared by laser ablation. AC conductivity have been increased by increasing the ratio of gold nanoparticle within BVA. Thus, this observation reflects the use of BVA gold nanoparticle sample in electrical application. Thank you.
Assalamu alaikum. This is Dr. Muhammad Afifi. I'm a researcher doctor at National Institute of Standards. Today I'm gonna present an article with title Alumina surface modified with hydroxyapatite sputtered via pulsed laser deposition technique for biomedical application. This work have been done with a cooperation with Dr. Muhammad Khalaf Ahmed, Swiss University, and Dr. Abdurrahman Antar Minazia, National Research Center. First of all, hard tissues consist of two main ingredients, mineral part, which is hydroxyapatite, and biological part, which is collagen. The great mechanical properties of bone tissue could be assigned to the ordered structure, which allows scattering the applied load within the bone tissue design. Hydroxyapatite is formed as rod shapes and scattered in an well-distributed thoroughly nanofibers of collagen. This configuration provides good tensile strength based on the nanofibrous contribution and high compressive strength upon the hydroxyapatite grains. Despite the high ratio of the porosity content, this fibrous tissue could prevent the fixation process between the implant material and the host tissue, and thus may weaken the load-bearing capacity and hence decrease the lifetime of the replacement tissues. Bioceramics such as titania, alumina, and zirconia are biocompatible substances and they possess high mechanical properties, good wear resistance, and were used for orthopedic and dental applications for decades. Alumina is one of the most bioceramics that has been used for biomedical applications owing to its unique properties. It does not possess the ability to establish direct chemical bonding with the host hard tissue and thus may lead to an immunoactive diffusion response. Therefore, to overcome this obstacle, hydroxyapatite could be coated on the surface of the bioceramic to enhance the adhesion behavior of the implement material. Moreover, the lifetime of the implement scaffold depends strongly on its degradation rate, which could be inhibited via surface modification. Different techniques have been used to establish layers of hydroxyapatite on alumina, such as chemical vapor deposition, arc plasma, and spray pyrolysis. However, one of the most feasible strategies for thin film deposition could be done via pulsed laser deposition technique, owing to its ability to produce homogeneous particles with narrow size distribution to be scattered uniformly on the alumina surface. In the pulsed laser deposition technique, the thickness of the fabricated film could be controlled via processing time. In this case, hydroxyapatite could be a target for the laser beam to be deposited in the alumina surface. It could be stated that this combination of hydroxyapatite deposited on alumina is classified as a ceramic composite. This type of composite could be introduced a superior mechanical alumina and biocompatible hydroxyapatite substance. This work aims to fabricate high-dense alumina substrate to be deposited with hydroxyapatite thin layer using pulsed laser deposition technique at different times of processing. The structural and morphological behavior of the produced hydroxyapatite at alumina film could be investigated. Besides, the mechanical and the response of fibroblast cell lines could be tested in vitro. The neodymium-YAG nanosecond laser system was used as the source of irradiation for deposition. The sputtering process of hydroxyapatite at alumina scaffold was done in a vacuum chamber that was evacuated at a pressure of 4.5 multiplied 10 power negative 5 Pascal at room temperature. All scaffold were processed at fixed laser parameter, including 1064 nanometer wavelengths, 10 Hz repetition rate, and 8 nanosecond pulse duration. The deposition was processed at variable laser time from 0 to 20 minutes for all compositions. This figure shows the phase identification using XRD for the deposition of hydroxyapatite on alumina substrate. For the undeposited composition, the alumina takes the crystal structure of alpha alumina was crystallized in hexagonal system with R-3C according to the ICDD card number 46/1212. The figure here shows field emission scanning electron microscope micrographs of hydroxyapatite at alumina scaffold at different deposition time. The first figure at top left corner shows the composition of time at 5 minutes, and it clearly shows that the grains of alumina were formed as a potato-like shape with dimensions around 1.3 up to 3 micrometer. The alumina grains seem to be rough due to the formation of microcracks. Moreover, a high ratio of intergranular porosity could be observed. For other samples, the latter spheres refer to the aggregated grains of hydroxyapatite, which have dimensions around 0.26 micrometer, reaching to around 1 micrometer. The intergrains porosity among grains of alumina tends to be filled with hydroxyapatite, which while the surface roughness is reduced considerably. The composition with high deposition time at time equals 20 minutes looks to be well covered with a high content of small spheres belonging to the hydroxyapatite. These spheres reduces both surface roughness and filled porosity ratio. The figure here shows the mechanical properties of hydroxyapatite at alumina scaffold at different deposition time extracted using ultrasonic technique. As you see here, the ability of the scaffold to sustain under various mechanical stresses may estimate its performance for different applications. In the figure, the dependence of the mechanical properties of the obtained scaffold upon the variation of deposition time using the ultrasonic technique. As you see here, shear modulus were decreased upon the variation of hydroxyapatite contribution from 142 to 112 to 22 gigapascal, while Young's modulus was reduced from 353 to 287 gigapascal for the samples start from 0 minute to 20 minutes. The reduction of the elasticity and the elastic modulus introduced a beneficial way to keep the implement biomaterial because it drops the stress shielding which occur when the implemented material hold elastic modulus higher than the bone itself, because this may lead to weakening of the bone. On the other hand, the micro hardness was enhanced significantly from 24 gigapascal reaching to 27 gigapascal with increasing the deposition time. This development of the micro hardness is assigned to the tendency of hydroxyapatite to fill pores among grains of alumina and thus increase the resist to the indentation process. Therefore, it could be expected that increasing of hydroxyapatite content through alumina may enhance corrosion resistance as well as mechanical performance. The Poisson ratio was changed from 0.24 to 0.17 with increasing the deposition time. The number of cells that will be alive after cultivation with the scaffold is a good sign to estimate the cytotoxicity of the implement material toward the physiological environment. The cell viability of the hydroxyapatite at alumina was carried out against the human fibroblasts cell line in vitro, and the results are illustrated in the figure you see here. It could be noticed that the minimum ratio was recorded with at t equals 0, which was about 87%, and increased upon the addition of hydroxyapatite on the surface of alumina, reaching 99.5% at the highest deposition time at 20 minutes. Also, the cell attachment, as you can see here at the scanning microscope images, the response of osteoblast cell line to have adhered over the scaffold surface is shown here at no additional hydroxyapatite as observed in the first figure, the figure Number A, no cell was detected on the surface. Consequently, modification of the scaffold surface could be considered as a facial strategy to manipulate bioactive scaffold for long life orthopedic application. The conclusion: hydroxyapatite was deposited on alumina substrate using pulsed laser deposition technique at different times. The effect of deposition time variation was investigated toward structure, morphological, mechanical, and biological response. It was reported that crystalline size of hydroxyapatite was increased upon deposition time, starting from 25 reaching 37 nanometer for t equals 5 minutes to the sample with time with 20 minutes in time. The computed lattice parameter indicated that C over A increased upon deposition time, and thus crystallization is preferred in C direction. The morphological variation upon deposition time indicates that alumina was formed as potato-like shape with dimensions around 1.3 to 2.94 micrometer. The hydroxyapatite grains were scattered over alumina grains with diameters about 0.27 up to 0.41 micrometer at time equals 5 minutes. The surface roughness behavior decreased upon increasing of deposition time, whereas the roughness average plunged from 53 nanometer to 29 nanometer with increasing the deposition time of the samples. The cell viability was enhanced with upon the increasing of hydroxyapatite content from 87 to 99.5% with increasing the pulsed laser deposition time, and thus compositions were biocompatibility toward human osteoblasts cell line. The cell line adhesion over the scaffold as well as the proliferation of the spreading of the cell were considerable improved upon raising of hydroxyapatite content on the scaffold. This behavior indicates that tailoring of new scaffold for orthopedic utilization could be done via pulsed laser deposition technique to manipulate controllable thin film of bioactive materials such as hydroxyapatite over high dense alumina scaffolds. Thank you.
Core shell of gold selenite nanoparticles incorporated via laser ablation technique into the polymeric nanofibrous scaffolds of cellulose acetate PVDF for wound healing applications. Now it could be reported that due to the fast development in the last decades, the number of accidents and the number of accident cases and burns and injuries, trauma has been increased exponentially, and thus created a new situation to deal fast with these wounds, to keep the people's lifestyle, and then new biomaterials should be developed to deal good with these injuries. The process of healing is a complicated process, and it could be mentioned that the requirements for the new biomaterial, it could be like biocompatibility and bioactivity, in addition to the adequate mechanical properties, high ratio of porosity. This porosity could allow the movement of nutrients and the formation of vascular system, in addition to the allowing to moisture to be transported. Therefore, and due to the similarity to the extracellular matrix, biopolymers which could be produced via via electrospinning technique could match with this requirement. We have different polymers such as BVDF or cellulose acetate, which are recommended as a biopolymers or as biocompatible polymers with good mechanical properties to be suggested for these kinds of applications. In addition to that, we have a big problem that could be correlated with the healing process, which is bacterial infection. Bacterial infection could delay the healing process, and thus it may cause healing failure. So, and to overcome this problem, antibacterial agents such as nanoparticles, such as selenium nanoparticles, could be suggested to be used as antibacterial substance. Therefore, the combination of these ideas could say that we have nanoparticles such as selenium and gold could be incorporated into the nanofibrous scaffold, like containing selenium, cellulose acetate, and BVDF. The metallic nanoparticles are produced via laser ablation. Laser ablation technique is a good way to fabricate nanoparticles because it doesn't need to chemicals or solvents, so it could be a fast way or a fast technique to produce the clean nanoparticles, and these nanoparticles then could be incorporated into the blend polymers containing cellulose acetate and BVDF. This blend could offer good mechanical properties, and then this mixture could be introduced to electrospinning or electrospun to be produced as a nanofiber for wound healing utilization. The obtained metallic nanoparticles, including gold, selenite, core shell, were tested or were scanned or examined by high resolution transmission electron microscope, and they seem to be formed as spherical shapes with inner diameter of 10.5 nanometer, and the outer diameter was around 25 nanometer. The surface morphology was examined by field emission scanning electron microscope upon the variation of compositional containing, and it could be shown from the micrographs that the fibers were formed with range around 30 to 70 nanometers, while with the additional of BVDF, the nanofibers were formed with diameters a range of 45 to 80 nanometers, and another group with diameters of 160 to 290 nanometers. In addition to that, it could be noted that the surface roughness was changed exponentially upon the variation of compositions, and as we can see from the table that the average roughness has been increased from 38.1 to 40 nanometers from the pure or the pristine selenium cellulose acetate to the highest dopant of gold selenite nanoparticles into the blend of selenium cellulose acetate on BVDF. From the table, it could be mentioned, or it could be observed, that the values of maximum high of the roughness are higher than their analog values of maximum roughness valley depths, and this could be indicate that the predominant factor of, or the predominant content of roughness is are peaks rather than to be notches. The peaks in roughness could promote the adhesion via physical technique rather than the chemical one. The physical technique is a good way to cross-linking between the nanofibrous scaffold and the biological environment, and thus could be good for the adhesion between the scaffold and the wound or with the skin tissue. The cell viability was examined again in vitro against human fibroblast cell line for 3 days, and the ratios exceeded, I think, around 95%, which indicates the high biocompatibility of these compositions. Then the compositions of the scaffold, the nanofibrous scaffolds, were cultured in vitro with human fibroblast cell lines for 3 days, and then these scaffolds were examined via scanning electron microscope, and it could be seen that the cells were proliferated and spread through the surface of fibers, and in addition we can see that these cells were adhered into the scaffold, and some of them were tend to be grow through the pores of the scaffold, which may indicate the good adhesion between the cells and the scaffold. So the conclusion, we can see that the surface roughness was improved and it changed upon the variation of compositions, and as an example, the roughness average increased from 32 to 40 nanometer. In addition to that, the in vitro culture of the nanofibrous scaffold with human fibroblast cell line indicated that the cells were adhered through the pores of scaffold, and thus the incorporation of gold selenite nanoparticles has promoted the adhesion, and thus the adhesion promoted the response between a scaffold and cell line of wounds, cell line of skins in vitro. Thank you.
Good morning. I am Ayman Mustafa, researcher in Spectroscopy Department, Laser Technology Unit, and the Molecular Spectroscopy Lab in National Research Center. And also, I'm a postdoctor in Center for Imaging and Microscopy in the Well City of Science and Technology. I want to talk today about synthesis of nanocomposite material by a pulsed laser ablation technique. I'll divide my talk to materials of nanostructure and its nanocomposite, the preparations method, and finally the pulsed laser ablation, especially in liquid environment. By looking in our life, everything on the earth has a special characteristic properties: color, smell, taste, reactivity, based on their constituent element. For that, the elements alone or in combination could be represent anything on the world: our bodies, our sun, our world, and the entire universe. For that, if you want to get new properties, we must find new material, and at this time we can get new application with new technology. In the last 2 centuries, there are 4 industrial revolutions, each of them based on certain type of material: textile, organic compound, computers. This industrial revolution produced an amazing social impact. The value of the social impact could be gained similarly by nanotechnology revolution, but in very small period. So, a lot of research has been done in this field to synthesize different type of material in a scale by different technique, and also to study their affected parameter which help to change the particle size and particle shape. That was related to the nanostructure material make a completely change in all physico-chemical properties: physically, chemically, mechanically, optically, or electrically. Due to once the material was prepared in a nanoscale, the quantum confinement phenomena was appeared, which meaning that we are making a confinement in at least one dimension to the scale of nanometer. And also, the free energy variation property was appeared, which meaning that increasing the surface to volume ratio due to increasing the number of dangling bonds on their surface as shown in this figure. In the modern technology like aerospace, underwater application, transportation application, we found the required materials in this technology need unusual and special combination of properties that couldn't be produced from conventional metal alloy, ceramics, and polymeric materials. For that, the nanocomposite material could be represent a good solution. A nanocomposite material is a multi-phase solid material where at least one phase of this structure has a nanostructure property. In the preparation method, there are different techniques could be used to fabricate nanocomposite material. Each of them has special characteristic properties. From this technique, laser ablation method was taken a lot of attention recently that was related to its fascinating properties, like it could be a green one to sense different type of material. It's inexpensive one. It has a lot of parameters which help it to tuning its particle shape or particle size. Let's start to talk about laser ablation process. It based on using an ultra-fast laser beam in a focusing condition by using a convex lens. This focusing beam make a laser-matter interaction. The irradiated surface from the matter, once absorbed these photons, it become to be ionized and generate an electron. This electron make a collision with neighboring atom to be ionized and generate another electron and so on. This process called electron avalanche process. After that, the plasma was expanded and a tiny particle was ejected from the surface of the matter. While in the case of laser ablation, especially in a liquid environment, once the laser matter interaction was produced, the front part of each pulse lead to be produce a laser-induced plasma. This plasma become to be increased due to plasma-induced pressure and the generation of laser shock wave. After that, there are number of kinetic process was carried inside the cavitation bubble due to increasing the high pressure and high temperature in compared with the outer shell from the liquid layer. Finally, once the plasma was cooling down, a tiny particle was ejected from the surface of the matter and go through the solution to be a colloidal form. So what is the difference in this technique in compared with others? Nanoparticle stability. We can produce a nanoparticle with high stability without using any surfactant. That was related to the produced nanoparticle has a charge in its surrounding surface, which prevent any agglomeration factors. Actually, there are a lot of factors in this technique which help it to tuning its particle shape or particle size. Simplicity. In this technique, it could be represented one of the simplest techniques because we just need a certain solution, a source of the sample, and container and laser source. That's it. Accuracy. Imagine we are make an ablation of a silver plate immersed in distilled water. The colloidal solution now is just nanosilver without any byproduct. Variety. We can sense different type of material. Safety. All of this technique was carried inside a liquid medium, so we are make sure there are not produced any side effect to the environment. In this technique, there are different factors can influence on size and composite of the produced nanocomposite structure. We can divide all of these factors to three types. First one is a laser parameter, like intensity, pulse width, ablation time, wavelength, rotation rate. This type affected mainly on the particle size of the nanostructure material. Second type is the properties of ablated material, as we can start from just a single metal or alloy. At this time we can produce nanoparticle or nanoalloy structure. The last one is the properties of environment. In this type we can produce a nanocomposite structure by changing the water solution to matrix solution. Matrix solution like multi-wall carbon nanotube, PVA solution, carbon nanofiber solution, and so on. There are another way by changing the water to metal precursor solution. In the metal precursor solution, which means that using metal salt, at this time we can also produce a nanocomposite structure solution. Let's give examples related to synthesis nanocomposite structure by changing the water solution to matrix solution. First example, once we are changing the water solution to tempo oxidized cellulose nanofiber and making an ablation of cadmium target immersed in this type of solution, we can produce decorated cadmium oxide nanoparticle on the surface of tempo oxidized cellulose nanofiber. The another example was related to make an ablation of tin plate immersed in functionalized multi-wall carbon nanotube to produce multi-wall carbon nanotube decorated with tin oxide nanoparticle. All of these examples was published already in high-impacted journals. Let us give another two examples related to produce nanocomposite structure, but with another way. This way was related to changing the water solution to the metal salt or metal precursor solution. First example was making an ablation of cadmium pellet immersed in DMSO solution. DMSO solution, it has a sulfur precursor solution. At this time, we can produce a binary compound from cadmium sulfide nanostructure material. The last example was related to make an ablation of zinc pellet immersed in ultra pure water to produce zinc oxide nanoparticle simply. But once we are changing the ultra pure water to chloroioric acid, and the chloroioric acid represented as a gold precursor solution, at this time we can produce gold zinc oxide core shell nanocomposite structure. That was related once a laser matter interaction was produced on the surface of zinc, a dense cloud containing a mixture of reducing species electrons ion free radical from zinc help to reduction of gold ion based on galvanic replacement reaction at this time led to making a core shell nanocomposite structure. Finally, I want to thank National Research Center for their facilities and thank you for your attention.
Good morning. I'm Iman Moifi, researcher in Physical Chemistry Department, National Research Center. My talk today about laser-assisted fabrication of carbon nanostructure membrane by electrospinning for water treatment. Our outlines, starting with introduction and introduction of wastewater problem, possible treatment methods, especially absorption method, the two used method for preparation of nanostructure. Firstly, electrospinning technique followed by laser-assisted method. Finally, we will finish with the parameters affecting the absorption efficiency. Beginning with an introduction part, water is life. Actually, there is no life without water, since up to 60% of our body is water, and the sources of water are limited, so we must struggle for solving this problem. On another hand, the quality of water is an important factor must be taken in consideration. But let us know, how can we obtain pure, clean, and safe water? This could be obtained by different treatment methods. But before we talk about these methods of treatment, let us know simply what are types of contamination exists in wastewater that could be disposed of. Our consideration here is localized on hazard metal compounds, where some of these metal compounds are toxic materials when it exists in high concentration. As an example, copper. When copper exists in a concentration up to 500 mg per liter, is considered as a toxic material. Moreover, there are other metals could be detected on wastewater and are harmful in high concentration, as zinc, cadmium, nickel, lead, mercury, and chromium, which required a lot of steps for the treatment. The main problem is this wastewater was discharged directly to the natural water. In this case, it was a risk for the ecosystem, and this direct discharge may affect negatively to the biological wastewater treatment. So that a lot of ways could be followed for this treatment, as bioabsorption, neutralization, precipitation, ion exchange, and adsorption. And adsorption is the method of interest. Adsorption method. Adsorption method is particularly the method of concern, as an efficient method for the removal of inorganic and organic hazards. Simply, this method defined as a transfer of a subject from a gas or liquid phase to be loaded on another surface. At this point, we must know two main items. The first one is the item of adsorbate, is meaning that the material being adsorbed. The another one is the adsorbent, which is meaning the material doing the adsorption, as cleared on the figure of the slide. In the adsorption process, there are a lot of adsorbents could be used, as silica gel, zeolite, and carbonious compound. But the main criteria of the adsorbent must be the stability and the surface area, so that carbon nanostructure, especially carbon nanotube, is a prominent adsorbent material. But there are some considerations to carbon nanotube surface, as the functionalization of carbon nanotube, where the main problem how to make the surface of carbon nanotube be active. This could be achieved by introducing a function group as hydroxyl, carbonyl, or carboxylic group, and this could be achieved by two methods, either by acid oxidation or air oxidation. The function group make carbon nanotube surface more hydrophilic and suitable for adsorption of hazard material. The adsorption of heavy metal on carbon nanotube depends mainly on the specific complexation between the metal ion and the hydrophilic function group on the surface of the carbon nanotube. Therefore, the surface functionalization of carbon nanotube is the measure of interest. But when we thinking to use carbon nanotube as adsorbent, there is a drawback of using a free carbon nanotube as adsorbent. The drawback is returned to how can we dispose of carbon nanotube after completing or finishing the process of treatment, as it will be soluble in the solution. For that, we thinking to load carbon nanotube on a supporting material as membrane to solve this drawback. This membrane could be nanofiber as a portable and recycled material. Simply, electrospinning technique is a cost-effective method to produce a novel fiber with diameter ranging from nanometer to micrometer. Electrospinning technique is a simple and multilateral method for producing continuous non-woven fiber with diameter ranging from micrometer to nanometer. Through this method, a large specific area with an excellent absorption capacity fiber membrane could be obtained. The electrospinning technique or system consists of three major components. First one is the high voltage power supply, spinneret, and collector. The polymer solution is pumped through the syringe with an automatic syringe pump. This syringe pump is positively charged using a high voltage supply, reaching to several kilovolt potential. The applied electric field causes fiber to be pulled from the droplet at the end of the needle grounded onto a collector. Why I choose to use this technique? The fibers produced by these techniques are very thin fiber. Moreover, they have a large surface area. The mechanism of this technique is related to the process of a solution of a liquid polymer fluid is put through a capillary device to produce a droplet. Under applied voltage on the droplet, which reduces the surface tension, resulting in a very thin fiber drawn out. The applied voltage is very high, is ranging from 8 to 50 kilovolt. Moreover, the diameter of the fiber is inversely proportional to the applied voltage. The fiber is drawn toward a collector plate by gravitational and electrostatic force and collected in the form of a mat. There are a lot of parameters controlling the nanofiber. We could talk about them in details as follows. The first one is the applied voltage. The strength of the applied electric field must be control the formation of the fiber. If the applied voltage is too high, there is a good chance of arcing, while if the applied voltage is low, there is no enough pull to form the fiber and the fiber will not be formed. The second parameter is the flow rate. The flow rate of the polymer solution in the syringe is another important parameter. Lower flow rate is more recommended for the polymer solution to get enough time for polarization, while in case of the flow rate is very high, the beads was formed with a thick diameter fiber rather than a smooth fiber. The third parameter controlling on the nanofiber is the collector distance, is meaning the distance between the collector and the tip of the needle, which affect on the fiber diameter and morphology. If the distance is too short, the fiber will not have enough time to be formed, while in case if the distance is too long, the beads could be obtained. The fourth factor is the spinneret or the syringe needle. The spinneret may be single tip, double tip, multi-tip, or core shell tip. This tip will be affecting on the shape and morphology of the resulted nanofiber. Another important factor affecting on the nanofiber is the molecular weight of the polymer. The molecular weight of the polymer affecting directly on the morphology of the nanofiber. The lower molecular weight polymer tends to form beads rather than to form smooth fiber, as shown in figure A. The beads are aggregated or spread in the picture. With increasing in the molecular weight, smooth fiber will be obtained as in figure B, but further increasing for molecular weight, micro ribbon will be obtained as shown in figure C. The final and the last parameter affecting on the nanofiber is the collector. The collector may be plate type as in the figure appeared on the right, or may be rotating type as in the figure in the left side. After successful preparation of the nanofiber, here the role of laser assisted method was appeared. There are a lot of strategies could be followed to load carbon nanotube on the surface of the nanofiber to increase the subjected surface to volume ratio of the membrane. One of these strategies is the pulsed laser ablation technique in liquid media, which lead to produce charged metal oxide nanostructure. This metal oxide nanostructure linking both carbon nanotube and the nanofiber membrane. This technique may be based on focusing ultrafast laser beam on the target metal source, producing laser matter interaction under a specific condition, forming plasma bloom, followed by producing very tiny nanoscale metal oxide. This tiny metal oxide linking carbon nanotube with the nanofiber, and the resulted decorated nanofiber composite will be applied in the remover of the wastewater treatment. And here, as shown in the schematic diagram, illustrates the steps of the obtaining nanofiber carbon nanotube metal oxide composite by electrospinning, followed by decoration of the nanofiber by carbon nanotube metal oxide composite. Finally, this nanofiber was tested for the removal of copper metal from the wasted water. But there are four main factors of study affecting on the absorption efficiency. Firstly, on number A is the pH factor, followed by nanofiber dose and the copper dose. Finally, the contact time for the absorption of metal on the surface of the nanofiber, and this work results was already published in high impact journal of radiation and physics journal as shown in the slide. Finally, thank you for your attention.
Bismillah ar-Rahman ar-Rahim. I will speak about a full-length article named Optical Emission Spectroscopy for Concrete Strength Evaluation Utilizing Calcium Lines. Was published in Optics and Laser Technology. The authors are Dr. Muhammad Mustafa Al-Faham, Mr. Muhammad Aqil, Dr. Nabil Nagi. Presented by Dr. Muhammad Mustafa Al-Faham, Associate Prof of Engineering Physics, Banha Faculty of Engineering, Banha University. The main task of this article is measuring the compressive strength of the concrete. We know that concrete is one of the most important materials in construction engineering. Evaluation of in situ concrete strength has become of great concern in construction process as well as for quality control. We know that there are many different destructive tests can be used to measure the compressive strength and the other performance parameters for concrete. In the present work, we want to measure the concrete compressive strength by using LIBS technique. LIBS acronym to laser-induced breakdown spectroscopy, as well as measuring the elementary composition of the concrete. We will measure the compressive strength of concrete by LIBS using the ratio between the ionic calcium lines at wavelengths 393.3 and 396.8 nanometer and the neutral line at 422.6 nanometer. We know that these lines are reversible lines, and they greatly have self-absorption. The self-absorption of these calcium lines was corrected via comparison of the electron density. These densities have been measured from calcium lines for the three calcium lines, neutral and ionic, compared to those of the hydrogen or H alpha line at 656.27 nanometer. We know that we will measure the compressive strength of concrete by using the LIBS technique. The main advantage of the LIBS technique is that it is a quick, semi-non-destructive, remote, and straightforward method. Besides, it can be used to measure the elementary analysis of the concrete. It is a technique in which matter, solid, liquid, or gas is excited to a plasma state by using high power lasers. The spectral emission of the plasma is affected by the concentration of the element in the sample and the plasma features. The plasma features, there are two main parameters of the plasma. Number one, the electron density and the electron temperature. We will measure the electron density and the electron temperature, which are the main parameters of the plasma. First, we will measure the plasma electron density. The importance of the electron density measurements depends on the ability to control the thermodynamic state of the plasma. It can be measured through different techniques, namely particle diagnostics or optical methods via optical emission spectroscopic technique that we will use in this manuscript or in this paper. The electron density of the H alpha lines. The plasma electron density of the H alpha line will be calculated from the equation seen in figure. Also, the plasma electron density of the other calcium lines as we said before, will be calculated from the following equation as shown in figure. Second, we will measure the plasma electron temperature. The interaction of the high power pulsed laser with solids release heated plasma with temperature altered from 6,000 to 20,000 degree Kelvin. In this case, we will measure the plasma temperature via Saha-Boltzmann equation, as shown in figure now. This is the parameters of Saha-Boltzmann equation, where J is the spectral line intensity, Gi is the degeneracy of the upper level, A is the transition probability, E is the energy level of the upper level, U is the partition function, and S is the total number density of the species in the plasma. Now we will speak about the effect of self-absorption on the spectral line emission, or spectral emission lines. We show from the figure now that self-absorption will affect the spectral line as shown in figure. It will decrease its intensity and it will broaden, I will do broadening on the spectral line as shown in figure. Therefore, self-absorption will be calculated from several equations or several methods. We will measure the self-absorption from the electron density of the line, or calcium line in this case, divided by the electron density of the H alpha line. N line, calcium line, we have 3 lines, 2 ionic lines and 1 neutral lines. The first one is 393, 396, this is the ionic lines, and 422, which is the neutral line, divided by the electron density, which is calculated before, of the H alpha line, power -1 over 0.54. Result and discussion. We see here before the relation between the ratio of calcium ionic to or over calcium neutral. For the calcium ionic, we have 2 calcium lines and 1 neutral lines, so we have two figures or 2 spectra as shown, the one below and the one above, in relation with the compressive strength or the mechanical compressive strength or the destructive compressive strength measured in the lab. There is no relation as shown in figure between the ratio of the calcium ionic over calcium neutral with the compressive strength. This is, in this case, is before correction of self-absorption. But after the correction of self-absorption as shown in figure, there is a ratio, or there is a linear relation with very high accuracy relation between the ratio of the calcium ionic lines to calcium neutral line with the compressive strength or the destructive compressive strength. So, as shown in figure, it is clear that the relation is a linear compressive or linear relation between the compressive tests, optical compressive stress, and mechanical compressive tests. In this slide, we draw a relation between the plasma temperature we calculated from Saha-Boltzmann with the compressive strength or destructive compressive strength. In this figure, this relation is before the correction of self-absorption, which means that there is no relation between the plasma temperature and the compressive strength, as shown in figure. But after the correction of self-absorption, there is a linear relationship between plasma temperature and compressive strength, as shown in figure with very high accuracy, R square point equal 0.978. Conclusion. This investigations highlights that the LIBS technique can be considered as a trustful non-destructive test. It has been used to determine the compressive strength by usage of the ratio of intensities between ionic to atomic calcium lines. Thank you.
بسم الله الرحمن الرحيم. My name is Asma Muhammad Ismail. I am researcher in Spectroscopy Department, Physics Division in National Research Center. My lecture is talking about synthesis and antibacterial activity of ketosane in lead by virus ratio of bimetallic gold silver nanoparticle via laser ablation. The outlines of my lecture is in the work, introduction, results and discussion, conclusion. In the work, we aimed in our work to prepare a film from low-cost material and studied their antibacterial activity to be used as wound dressing application. So we shall use ketosane, silver and gold nanoparticles in our system. So we prepare an individual solution from silver and gold nanoparticles using laser ablation method by focusing laser beam on a metal plate as seen in the slide. Then prepare different volume ratios of both and adding to ketosane solution and prepare ketosane, silver and gold films using casting method. We studied the effect of both silver and gold nanoparticles on structure, optical and antibacterial activity of ketosane. We use ketosane because of its renewable polysaccharide deriving from calcium. It's low-cost polymer and has two active sites and two functional group OH and NH group that makes it surface more interaction with other metal and metal oxides, and there is structure of ketosane. We use both of silver nanoparticle and gold nanoparticle to produce a metal alloy because of silver nanoparticle can be used as cytotoxicity material and gold nanoparticles can be used as a heat generating material. Results and discussion. We studied the effect of both silver and gold nanoparticles on structure, optical and antibacterial activity of ketosane. So, X-ray diffraction of our system as seen in figure that ketosane shows a diffraction peaks at 8.4 and 90.9 and 21.9 as seen in figure that for ketosane doped with silver nanoparticles that the peaks of ketosane at 19.9 and 21.9 disappeared and new diffraction peak appeared at 20.3, which is broader than that in ketosane. There is another peak at 2 theta equal 32.3, 35.6 and 44.5 for ketosane doped with gold nanoparticles. Also, the characteristic diffraction peaks of ketosane and gold nanoparticles disappeared, and a new peaks appeared at 2 theta equal 14.1 and 19.6. As seen in the figure that with increasing the ratio of gold nanoparticles, the diffraction peaks of ketosane become less broad, and the diffraction peaks of silver nanoparticles at 2 theta 32.3 disappeared. So both of silver and gold nanoparticles have comparable electronegativity and atomic size. Also, it's crystallized in the phase center cubic structure shape, so it's difficult from XRD to determine the formation of the bimetallic nanoparticles. As a result, it's considered that the weak peaks appeared in the spectrum represent a great disarray in ketosane chain alignment with the development of new peaks, which suggests that the presence of ketosane dope with silver and gold nanoparticles, and there is a complexation happen between them. And we studied the functional group and the reaction between ketosane with both silver and gold nanoparticles. For pure ketosane, there are stretching vibration of OH and NH group at 3369 and 3316, and the bands of amide 1 and amide 2 at 1646 and 1560. It can be seen that for ketosane doped with silver nanoparticles and ketosane doped with gold nanoparticles, the intensity of OH and NH stretching and bending vibration absorption band are decreased compared to pure ketosane. That means the creating of gold nanoparticles and silver nanoparticles with OH and NH groups. As seen in figure from 2C to 2F, that ketosane doped with various silver and gold nanoparticles, that spectrum 2E has lower intensity in vibration band compared with other ratios that have nearly same intensities in vibrational bands. That means ketosane doped with 3 gold and 2 Ag nanoparticle is the most reactive ratio with ketosane. We studied the optical properties of ketosane doped with various ratio of gold and silver nanoparticles using UV visible spectrophotometer. As seen in figure 3a, that ketosane has a maximum peak at 201 nanometer, which corresponded to N-acetyl glycosamine and glycosamine of ketosane. In figure 3b and 3g, there are an additional peak at 410 nanometer and a weak peak at 528 nanometer, that corresponding to the peaks of silver nanoparticles and gold nanoparticles. As with increasing gold nanoparticles ratio, that the peaks at 410 and 528 nanometer disappear. That means the complexation between ketosane and both silver and gold nanoparticles alloy, and this result agreed with the data in XRD and FTIR spectrum. The absorption edge values for ketosane and ketosane doped with various ratio of both silver and gold nanoparticles can be estimated by plotting the optical absorption coefficient alpha with photon energy H nu and extrapolating the linear progression of the curve with zero values of photon energy. As seen, the values of absorption edge are decreased compared to pure ketosane. That means gold nanoparticle and silver nanoparticle is affected on the arrangement of atoms and the crystallinity of ketosane. The density of electronic transition are decreased exponentially with energy in band tails between located state and its characteristic property for large number of amorphous material, and band tail energy are estimated by using Arbach equation. Values of band tail increased compared to pure ketosane. That means dependence of exponential of alpha on N energy result in structure disorder because of the random fluctuation of internal field in ketosane because intermolecular interaction resulting from doping it with silver and gold nano. The optical band gap energy that occurred from photon transition can be estimated by using Mott and Davis extrapolation method. As seen, the values of both direct and indirect optical band gap are decreased with increasing ketosane doped with silver and gold nanoparticles compared to pure ketosane, and that means silver and gold nanoparticles metal alloy created defect in structure of ketosane, which lead to increase the number of energy level orbitals as well lead to structure disorder. The differences of diameter zone with pure ketosane and ketosane doped with various ratio of silver and gold nanoparticles have been examined. It's observed that for pure ketosane, the values of inhibition zone in both 2 gram negative and 2 gram positive obtain low values. The maximum value is 8 mm in both B. aeruginosa and S. arosa, and the minimum value is 6 mm in B. spatellus. In S3 sample, we show that the high antibacterial activity related to its value of inhibition zone. The maximum value of inhibition zone is 21 mm in S. arosa, and the minimum value is 19 mm in E. coli. This result could be attributed to that silver nanoparticles could penetrate the cell wall of bacteria more than gold nanoparticles, but in a certain ratio S3, gold nanoparticles can contribute with silver nanoparticles to enhance the antibacterial activity of ketosane. This may be assigned to the chemical composition of bacteria cell walls or the biological structure of bacteria membrane. The observed results in the current work confirm that ketosane doped with 2 gold nanoparticles and 3 silver nanoparticles possesses a potential antibacterial activity against the given bacteria. Conclusions. Ketosane doped with various ratio of silver nanoparticles and gold nanoparticles have been sensed via casting technique and study its antibacterial behavior. Silver and gold nanoparticles have been sensed via laser ablation route. From X-ray diffraction, the increase of the ratio of gold nanoparticles and decrease in silver nanoparticles concentration, the broadening of ketosane peak at 2 theta equal 19.6 decreased, and the diffraction peak of silver nanoparticle at 2 theta equal 32.3 disappeared. For FTIR, the intensity of OH and NH stretching and dependent vibration absorption band are decreased compared to pure ketosane. That means the chelating of gold and silver nanoparticles with OH and NH group. The observed results in the current work confirm that ketosane doped by 2 gold nanoparticles and 3 silver nanoparticles possesses a potential antibacterial activity against the given bacteria. And finally, thank you.
At the end of the session, it gives me great pleasure to thank all of the speakers for their interesting talks. Now the time for the open discussion session, and thank you for opening.